Alright, it's time for the solutions for the Master Quiz number 6 review. What I'm going to do, because I did tell people to do the evens only, on this video I'll do evens, and then the next one I'll do the odds for those who care to know what the odd ones are. So on number 2 here, this has a lovely pattern of starting at -19, and then going -24, and then -29, and it's just subtracting 5 each time. So this one has a common difference of -5, which makes it arithmetic. Make sure you know what type it is. And, oh wait, that's over here. So arithmetic. And the next few terms are going to give you -39, -44, -49. And so we got the initial value and the common difference. Initial value is -19. So the recursive function is going to be a sub n equals a sub n minus 1 plus, well, more like plus -5 or just subtract 5. A sub 1 is -19. I'm trying to make that. There's not really a lot of room there on the right side. My bad. Okay, the explicit formula for all arithmetic sequences starts out like this. A sub n equals, then you put your common difference, -5, times that by n minus 1, and then add your initial value, or such as plus -19. And there you go, explicit formula. And to get a sub 12, you're going to take your explicit formula and put 12 where you see the n. So we're going to do -5 times 12 minus 1, and then we're going to plus -19 or just subtract 19. 12 minus 1 is 11. And then -5 times 11 is -55. And if you subtract 19 from that, let's say -55 minus 19, you're going to get your answer, which is, it's going to give you -74. So is that one. Switching over to number 4, we have this lovely pattern here of timesing by 5 every time, which means we're going to have a geometric sequence. And our common ratio is that number we multiply by, which is 5. The next one's going to be 625, and then 3125, and then 15, 625, 5, like that. So, yeah, so those are our numbers there. The recursive formula, you need your common ratio, which is 5, and your initial value, which is 1. So, the recursive one, a sub n equals 5 times a sub n minus 1, and a sub 1 is 1. You need both of those pieces there. The explicit formula is going to be a sub n equals, you're going to put initial value times your common ratio to the n minus 1 power. So there's your explicit formula. If you want a sub 9, you need to take your explicit formula and put 9 in for n. So you can do 9 minus 1, which is 8. So you have to do 5 to the 8th power, which is 390,625. Yeah, and that's why we use calculus, because you get some really big numbers in that. So let's jump over to 6. We have this nice pattern here of just adding 11 each time. So we're going to get 64, and then 75, and then 86. Just adding 11 each time. And since we're adding 11 each time, it has a common difference. This type of sequence is an arithmetic sequence. So we're going to use that common difference of 11 and our initial value of 20 to write our recursive formula. So a sub n, any number, is equal to the previous one plus 11, and when you start a sequence at 20. So that's our recursive formula, our recursive function. The explicit one, awfully similar, but you have to do 11 times n minus 1, and then add 20 on the end. And so there's our explicit formula. If you want to get a sub 6, we already got it. Secret. Alright, so this is 1, 2, 3, 4, 5, 6. It's 75. Yeah, if you don't have to do the work, don't bother. It's 75. Ta-da! Next one. Moving on to 8. because we just did 6, right? Yep, okay, we just did 6. So looking at 8 here, it's looking like, let's see, 3 fours, 5 fours, 7 fours, 9 fours. It's looking like we're adding 2 fours every time, so we're going to get 11 fours, and then 13 fours, and then 15 fours. Okay, so we are adding the same amount each time. Well, the amount we're adding is 2 fours, or 1/2. And to figure out what type it is, you're adding the same number every time, so it's arithmetic. I'll put in parentheses here that that's 2 fours, because that's what you're adding each time. If you want the recursive formula, you're going to start at 3 fours. So I'll put that first this time. So the first number in the sequence is 3 fours. And the pattern is every number is the previous one, a sub n minus 1, plus 1/2. And if you want the explicit formula for an arithmetic sequence, you're going to have you're going to have 1/2 in front of n minus 1. And then you're going to add the 3 fourths there. So there's my explicit one ready to go. If you want to get a sub 10, you're going to take your explicit formula and plug in 10. So a sub 10 is 1/2 times 10 minus 1, and then plus 3 fourths. Since all these numbers are fractions, we're going to keep them as fractions. If you do 10 minus 1, you get 9. If you get half of 9, you get 4.5, also known as 9 halves, which is the same thing as 18 fourths, and if you add 3 to that, you'll get 21 fourths. So there's your a sub 10. And we'll move on to number 10 here. We kind of have an odd pattern here of switching between positive and negative, positive and negative. Well, if you're going to do that, you have to be multiplying or dividing by a negative. There's no other way. You're going to be switching back and forth like that on arithmetic and geometric sequences. So this one is going to be geometric. And it's going to have a common ratio. If you don't know what the common ratio is, you can take any number in the sequence and divide by the previous one. So let me do that real quick. 200 divided by negative 1200 is going to give me negative 1/6. And so that's what we're multiplying by every time. So if you want to get the next one, you're going to have a positive 100, but on bottom you have to do 100. Well, you have to do 1/6 times this, so negative 1/6 times that, which is going to give you, it's going to give you 100 over 18, which when you reduce it down, alright, that one's going to give you 59 when you reduce that down. Let me get my space a little bit more space again. If you want to get the next one, you times by negative 1/6, so the next one's going to be negative 50 on top. On bottom, you're looking at, gosh, these fractions are kind of ridiculous. So you got negative 50 on top, and on bottom, you're going to get 54, which, when you reduce it down, is going to give you negative 25/27. And if you take that and you times it by negative 1/6, you're going to get positive 25 on top, and on bottom, let's see, 27 times 6 is going to give me 162. And so there's my next week's terms in the sequence, which is kind of a pain to get, but you can do it anyway. Just use your calculator, let it do it for you. It's really handy. If you want to do the recursive function, make sure you're doing the geometric type, which involves you doing 1/6 or negative 1/6 times a sub n minus 1. And the first term of my sequence is 7200. Add that in there. And run a space on the right side. If you want the explicit formula, a sub n equals start value of 7200 times 1/6 negative to the n minus 1 power. So there's my explicit formula. If you want to get a sub 9, you're going to take 9 and plug it into your explicit formula. Negative 1/6 to the 9 minus 1 power. And when you do that and simplify things down, you're going to get about 0.004287, which is a fraction that I am not going to figure out right now. Anyway, moving on to the next one. Number 12, we got a very prestigious chess club participating in a chess tournament, and it represents how many games being played during each round. I'm noticing a pattern right away that it's just dividing by 2 each time. And, well, hold on for a second. Well, this one doesn't tell me to write a function, so I'm not going to, because, well, I'm lazy. And you can just figure it out by keep going on. 6 rounds, 7 rounds, there's only 2. 8 rounds, you get 1. So it's going to be 8. Ta-da! That's number 12. Moving on to number 14. Bacteria multiplying at an alarming rate. Splits 2 nest cells, thus doubling. Start 1 bacterium. Doubles every hour. So every hour it's going to double. So your common ratio is going to be 2, because you're going to times by 2 every hour. Your initial value, C, well, it starts at 1. So those are our 2 numbers. I'm going to write the explicit formula. So that's 1 times 2 to the n minus 1 power. And there you go. At the end of one day, which is 24 hours, and we're going to have n. Our n is the terms in the sequence. The first term, the 0 hour, is not hour 1, so we're going to have to plug in 25. So we're going to have 2 to the 25 minus 1 power, which is 2 to the 24th, which is going to be a really stinking large number. Hold on. Okay, I guess that's not too bad. It's just about 16,777,216. Moving on to 16, buy a new computer for $2,100, decreases value by 30% annually. So you're losing 30% each time, so you're going to keep 70% is what's staying, which corresponds to 0.7, by the way. And so that's actually your common ratio, which those are all equivalent. And so when I write my function, I'm going to do the explicit one. It's going to start at 2,100, and you're going to times by 0.7 each year. So that's going to have n minus 1 on it. And what's the value of the computer 5 years after purchasing it? So remember, year 0 is the first term of the sequence. So if you want to get how much is 5 years in, you have to get the 6th term of the sequence, 2,100 times 0.7 to the 6 minus 1 power is going to give you, it's going to give you about 352, I'm going to write that up here, $352.95-ish cents, and we'll just round it up because that's pretty normal. Just round things up when it's above 0.5. Anyway, so there's that. And moving on to number 18, we just have a linear or arithmetic sequence here. So this one's arithmetic. It has a pattern of adding how much each time. To figure that out, you can just write what the sequence is. So let me do that real quick. Okay, so we're getting that our common difference is what we're adding each time, which is going to be 2. The initial value is going to be 0. So on your recursive formula, you're going to have a sub n equals every term is the previous one plus 2, and a sub 1 is 0. The explicit one is going to be a sub n equals 2 times n minus 1, and you're adding 0 on the end, so it really doesn't do anything, just leave it like that. If you want to get a sub 8, you're going to plug 8 in for your n value. 8 minus 1 is 7 times 2 is 14, so a sub 8 is 14. And that brings us to number 20. So let's, man, this one's got a really blurry little screen here, but luckily they put all the numbers there for you, which is awfully convenient. So let me write those down real quick. Okay, as I look at this one, this graph, kind of a pain in the butt to even read, and I can't get definite numbers out of it. That's crap, or definite pattern. And so we're just going to skip that one. All done.